And we'd like to welcome in on the Open Alliance Show, team number 3636. Generals coming in from Portland, Oregon in the PNW area. We have Charlie and Peter joining us from that team. Hey, why don't you mind introducing yourselves? Tell us what you do on the team, and we're going to jump into this pretty awesome prototype that you guys have on screen as well.
All right, yeah, I'm Charlie. I'm the co-captain of the team, and I mainly deal with the CAD and design side of things.
Yeah, I'm Peter, also co-captain, and I'm the mechanical lead.
Your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Stryker Careers. Stryker's commitment to medical device technology innovation has made it a top career destination for those in FIRST. FIRST alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. Well, welcome.
Yeah.
We're excited to talk to you about what your team's been working on. Obviously, you got a couple of weeks under your belt already, so we'll very briefly where we are, how you got to this point. But then obviously want to jump into, you got CAD models, you got prototypes, you got a whole bunch of different other stuff. Cool. So give me a quick elevator speech. How have you tackled Rapid React and bring us up to speed to where you are here in week 3?
Yeah, of course. So Rapid React, first of all, yeah, it's just really great to have a real game again, and just be doing a real build season. But the way we've approached this game has definitely been from a perspective of like raising the floor before we raise the ceiling. That's kind of my go-to slogan for design philosophy.
Yeah.
And so we think that the low goal and the mid climb are going to be two of the most important ways to consistently score points in a match. And so we want our robot to be able to do those consistently at the bare minimum. And then from there, we can expand and branch out into trying stuff like the high goal or maybe even the traversal climb. So that's pretty much where we're at in terms of design goals.
Yeah.
So looking,
That's awesome. Yeah, I mean, so
you're good.
Go ahead, Tyler.
No, you're good. Go ahead.
No, I was gonna say, so looking at that objective of being, kind of straightforward and, direct about low goal and mid climb and keeping those priorities square, you've got quite the prototype in front of you. So do you want to just jump right in and talk about what this prototype and where you are on week 3?
Yeah, sure. And I can actually go into our CAD model and dig a little deeper here. So we essentially, starting with the intake, I guess, because that's sort of where it all starts, the ball going in and out of the bot. I would say we kind of learned our lesson in 2020 about through bumper intakes. The one that we built for our bot was not ideal. It took a really long time, and it had a tendency to jam up on the power cells. And so pretty much from the second we saw that it was the game piece was a ball again, we kind of knew that we needed to go over the bumper. There were some moments where we discussed different strategies, but in the end, we just, after seeing how reliable and how good over the bumper intakes were in 2020, it didn't really seem like, it didn't really seem like it was that much of a question, really. So we've got this full width over the bumper intake using the ThriftyBot compliant wheels, of which there are quite a few, and then it actuates on this linkage here, which lets it get tucked all the way inside the frame perimeter, even in our small frame. Also, actually, I should say this. Another thing we decided on pretty early in the season is building the robot within a 24 by 24 kit of parts chassis. And so that decision was made just to make it a lot easier to climb with other alliance partners, which we think is going to increase the consistency of earning ranking points. But anyways, I'm getting kind of into the weeds here.
No, we love it. We love it. Get into the weeds as much as you want. This is great.
So the feeder system that we've got here, and I can actually go into the subassembly, is this is going to take a while.
Yeah,
isn't it? Sure. It's a fairly simple conveyor system, and so originally we were planning to run this. We had all these belt paths planned, and it was going to be this, this two-sided thing. We were going to have a diagonal belt going across the corner, and then two on either side, and wheels everywhere. And what we discovered pretty early on is, these cargo balls here, they are just great to work with. They can slip and slide against pretty much any surface. And so what we realized was basically all we need is just a single, set of timing belts here, and then everything else is just bent polycarbonate. And so the other thing we've used is these like passive, these fins or sort of guide systems. And you can see these, or can you see these? I don't know. In front of the feeder, and so these basically take the wider area or the wider width of the intake, and then funnel it down into our smaller storage feeder tube area. So this was kind of the first thing we started prototyping, just because it was pretty straightforward to build. As you can see, the prototype here it's just some 80-20 with some basic laser cut wood gussets, and then these bent polycarbonate pieces were also fairly easy to make since we have access to a press brake here in our shop. But yeah, that's about where we're at with this specific mechanism.
So I know there's only two cargo coming in. Have you done any experimenting though in regards to like jamming with the way you're kind of filtering in or anything like that? Or do the balls just kind of just rub off each other? You don't need to worry about that at all.
That is one thing that we have yet to fully test, but we have tested from even the very extremities of this. They will get sucked in, and that is obviously one thing that we plan to test in the very near future. Especially once we get our intake integrated with this whole unit with our indexer, and then eventually the shooter. Yeah.
Very cool.
But yeah, based on what I've seen and what we've tested with these balls, I would find it pretty likely that they're just going to sort of rub off of each other and find a way to get in line. Like I said, these are definitely a lot more forgiving of a game piece than power cells.
Yeah, what a year, huh? Where we had students and stuff saying, "Hey, these are actually pretty nice to work with." So
I know, yeah.
I was like, "Wow, I didn't think I'd ever hear that statement." So
yeah. Well, I mean, they're certainly not saying about the climb.
Yeah. So you talked about earlier on about how the low goal was something that you wanted to make sure that you focused on. Is this shooter that you see in front of you, is that a low goal shooter, or is it something that'll do the upper goal and the low goal depending on speed, or what's your thinking there?
Yeah. So we have tested this, and it can do both low goal and high goal. Obviously not extensively, but we definitely plan to be able to do both. Especially because for that ranking point in qualification matches, it makes sense to go for the low goal, and then during eliminations, switch to high, where then it's more just point based. So yeah, and this shooter definitely should be able to do both.
And is that going for a specific shot? Like, are you trying to shoot like right off the fender?
Yeah,
or are you trying to shoot from further away?
Yeah, right off the fender. We decided pretty quickly that's definitely going to be the easiest thing. It's hard to defend, and it's definitely going to be pretty consistent. Yeah.
And based on what we've been seeing from a lot of other teams' tests, specifically 7492 with their fantastic analysis of the bounce out on this upper goal, it looks like about that fender area is going to be the most consistent way to score both the high and the low. And what we think we might be able to do is still a bit of an if, but we're working on testing this right now with programming, is the idea of having the rollers, because it's a dual roller design. We were initially going for a more traditional like 2020 style hooded shooter, and what we realized from a lot of these other teams testing was that having that backspin on the ball was leading to a lot higher rates of the ball bouncing out. So the dual wheel made sense. But what we're actually looking into right now is if we can run these rollers at different speeds, we're trying to figure out a way where we can decrease the backspin for that high goal shot to reduce the risk of bouncing out, but then actually increase the backspin for the lower goal shot to make it potentially more consistent in that as well.
That's a very, very cool idea. Are you playing with like the different wheel types also to vary that as well? Because you've got like high grip wheels on one side and Colson's on the other. Is that part of that same spin strategy?
Yeah, so we started with all high grips, and it just was really not that effective. That from our testing, on the top and bottom, and we actually just received some Colson's, and they've even just on the bottom roller, they made a huge difference, especially for the high goal shooting. And we plan to switch our top rollers out to either some more 2-inch or 4-inch Colson's, or even down to like a 2.5-inch Colson or something like that. So we definitely are going to be testing more of our options there. Yeah.
So
Yeah,
those
and
wheels
the
currently
current-
are not powered, right? Where the high grips are.
They are. Yes, they will
would be. Yeah, they
Okay.
will be. Right now, the motors aren't hooked up to anything.
Yeah.
And the pulleys are not functional.
Yeah.
But yeah, so if you look in the CAD, the current iteration has, or you have the mouse set to the wrong way. I was trying to see when it zooms out. We have the 4-inch Colson's on the bottom, sticking with those, and then up here we have the 2.5-inch. But we're definitely going to. We did place an order earlier this week for quite a few more Colson wheels, so we're going to just be playing with the different sizes and different setups to see what works the best and what gives us the most consistent shots.
How about some other aspects of your robot? Let's dive into different parts. We do see a little bit of a climber on there. Anything else that you want to dive a bit more into and talk about from both the strategic and also from a mechanical side?
Yeah, I can talk about the climb.
Yeah, you can.
So our climber design, as you can see down here, is pretty simple. We're using the ThriftyBot telescoping tube kit, which we managed to snag 2 of on kickoff before they went out of stock. And so it's just that, and then down at the bottom, it is powered by a Max Planetary gearbox, actually. And then that's secured onto the tube just using these side gussets. And then if we look inside here, you can see we've got, we're just using the shaft itself as a spool for the rope, and it just goes straight up and into here. And then we've got a pretty elaborate mounting system down here that is hopefully overbuilt enough to guarantee that our robot's going to stay up every match. But yeah, so our goal for the climber this year was, the mid climb. From what we've seen of the strategy is definitely like it's after 2020. Just climbing up to a bar is kind of a known thing, especially with all these new COTS kits. And so we just figured, we want to build something that's going to be the most effective thing for the least amount of like prototyping effort. And so going with just a COTS climber kit with a COTS gearbox on the bottom just made sense. So we haven't done really any prototyping on it. We actually did receive our climber kit a couple of days ago, but we haven't assembled it yet.
Sure.
Because somehow every metal store in Portland is out of 2x2 box tube, and we need that. But we're working on it. We're hopefully going to get some of that from some online vendor in the next couple days. But anyways, the climber basically is just designed to be simple and effective and get us that mid climb every single match. Oh, and the other thing is the hooks. So these hooks, again, I had to zoom out. The hooks are double-sided. And actually I have one of them right here. We machined these a couple days ago.
Yeah.
Not a couple days ago. It was like last week. Okay. We have the hooks. We actually have all of them, all four. And so the double-sided hooks, we figured, you know, why not? Basically, why not give ourselves the ability to climb, you know, from whatever direction and whatever angle we want. And then these latches here, we're actually not sure if we're going to have on the final version. They were designed by 6328, who actually they were just on the show.
Yep.
We had them on earlier.
But yeah, so these were what they used in 2020 for their climber, and basically we thought they were cool, and you know, figured we might add them, but I'm not sure that they'll be quite necessary, especially since, you know, if we want to end up doing the traversal at some point down the line, then a latch is kind of exactly what you don't want.
Let me ask you.
Yeah.
Looking at since you mentioned that the traversal is a potential for it, you know, how would you potentially package into what you have right now? Like, what would you modify, or what thought processes have you had in regards to the traversal rung?
Yeah, so most likely what we do is take the current telescoping hooks that we have right now and attach those to some type of pivoting system, and then add some more probably to the main superstructure that would then have some passive hooks, because it seems like a lot of teams we've seen are able to just use one set of passive hooks and then a telescoping climb with some more hooks to lift themselves up to the high-end traversal bars. Yeah.
Mm-hmm. Yeah. So yeah, from what we've seen, I believe 1339 and 3512 both have a pretty similar design in terms of just the passive hooks mounted in the middle, and then the two pivoting telescopes on the sides. And as far as like packaging that within our drivetrain and within the rest of the robot, I've been trying pretty hard not to think about that, but it's doable, I think, for sure. And it would most likely just involve just making some modifications to the kitbot chassis, putting some more box tube on there, and you know, figuring out a way to put a pivot point on there.
Yep. So we have a question from the chat. Right now, it looks like your bot has no pneumatics on it. So what are you using to actuate the intake in and out?
Oh boy, yeah, this is fun. So yeah, we are not using pneumatics this year. We actually haven't used pneumatics in quite a while. Yes, we're working on it.
We might decide to add them for the.
Yeah. Right now, based on our objectives, they're not super necessary, because it's kind of the only thing we would need them for is an intake. And so in place of that, the somewhat janky solution that we've come up with is this winch, actually. So if you've noticed this bar of hex shaft just kind of floating out here, this is our intake deployment. And so it's powered by a Falcon motor on another Max Planetary down here. And it actually uses the same plate that attaches to this Neo 550, which powers our conveyor. So this would basically we would put some kind of rope on either end of this between these two shaft collars, and then run that to a point somewhere in this intake, most likely something around this location. And so the way that would work is just sort of, you know, you pull up on the winch and it pulls up the intake. And because of the way the linkage deploys, because it kind of goes from like vertical to horizontal, it would be able to have I think a pretty consistent amount of force all throughout that deployment. So this is definitely something that we're going to need to test, but
yeah, we think it could work. And then the only issue we do see with that method is holding it down. So when balls are coming in, it doesn't just get kind of bucked up and then becomes ineffective. So we are also thinking about using maybe just a motor, just driving it a more standard way, or even we might add pneumatics, but yeah, I think our main off the winch.
Has your team ever looked at like sealed gas springs?
Actually, yes. So we were thinking about gas springs initially for this intake deployment, as well as in 2020, but we never got a chance to use those, unfortunately. But what happened, well, we sort of, the realization that we came to and why we're not choosing to use gas springs is just that in this game, an intake that only deploys once and sits out there for the rest of the match is probably going to get pretty banged up by defense.
Pretty open field.
Yeah.
Well,
and not a lot of driver visibility, especially behind that hub.
Yeah, but even something along the lines of like if you use your winch mechanism to pull it up, right? You can do like a small like 5 pound or 2 pound spring to push it down, and then you can overcome the spring with the winch to bring it back up. But that
that's actually the option that we're thinking of is using either that or just plain old surgical tubing as a way of adding some force to the intake when it's down. Because from our tests, in order to get an ideal amount of compression on the ball, we needed to, push it down manually. Otherwise, as soon as the ball went in, it was just sort of, making the intake go up, and then that wasn't giving us as much grip.
Well, so as always, time is always short with these, and we do have to start wrapping up. It's been fantastic here about your team. I think before we go, though, I'd like to see, I want to put your 30-day test in regards to your belting. Can you hand feed in a couple of those cargo, and can we actually see it come up through the belting? I'd love to see a demo of that.
I can bring this out
Here.
Is that
there.
good?
Yeah, that's good.
we can see it. Yeah.
So,
Yeah. So
here.
That's slick.
Yeah.
I love it.
And that actually might have ran that a little too far.
Yeah, still some testing to be done, but
Hey, it still worked even with that belt falling
That's
off.
the programmer's
that's one of the
issue
ideas.
to worry about later. Don't worry about it.
yeah, because
Just throw a sensor there, call it done.
Yeah, that is actually our plan.
Yeah.
Just put a sensor, somewhere in this general area, and then leave it to the programmers to figure out how to, make it not undo the belts every time we take a ball.
Well, 36
nice
generals.
having them.
Yeah. Well,
Yeah,
36
luckily, I see what
generals,
happened
thank
right
you
back.
so much for taking the time. We unfortunately do have to head out, but we really appreciate hearing more about your robot, seeing some of the cool demonstrations, of course, the CAD drawings as well, too, and the CAD designs. So, of course, your team will be on in a couple more weeks. I can't wait to see where your progress is. I got really high hopes for your team, and I can't wait to see more about it. So thanks a lot for taking the time.
Great.
Well, thank you. Yeah, I appreciate the kind words, and we are happy to come on the show again in a few weeks.
Yeah.
Hopefully, we will have a lot more robot by then.
Yeah, thank you for having us on today.
Yeah, thank you.
Thanks to Stryker Careers for their support in this video. Stryker's commitment to medical device technology innovation has made it a top career destination for those in FIRST. FIRST alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter. And First Updates Now on Facebook, Instagram, TikTok, and Twitter.